So you can either type in the address, or if you go to Canvas, there's a link. And if you don't have a Chromebook or a tablet with you, I have a couple of Chromebooks that you could borrow if you need to. The easiest way is going to be to go to our Canvas homepage. And once you're on the homepage, you'll click on Modules. And then you go to Wednesday 1/8 right here. And if you scroll down just a little bit on this page, underneath task number 2, what does 95% confident mean? There's a link right below that that says confidence intervals for proportions applet. Click on that and it should take you to a page that looks like this. So again, go to the Canvas homepage, go to Modules and find today's date, Wednesday 1/8. Scroll down a little bit until you see task number 2 and click on the link there. You can also type in the address, but make sure you do CI and not CL. If you type in the www.tinyurl.com/applet and then it's a capital C and a capital I know it looks like a lowercase l, but if you put in a lowercase l, it takes you somewhere else. All right. Can you give me a hand real quick if you're still working on navigating to this page? Okay, gotcha. All right, so we're going to start working our way through the directions here on this page. One says we're going to use this applet, set the population proportion to 0.5 and the confidence level to 80% and the sample size to 100. So back here, population proportion should already be set at 0.5. If not, drag the slider until it's at 0.5. We want the confidence level to be 80%. Right now, mine is set at 95. I'm going to drag it, if it'll let me. It doesn't like it very much when I'm touching the screen. You should be able to grab that little box and drag it over. 80% should have it all the way over to the far left edge. And then we wanted to take the sample size up to what? Up to 100. So I'm going to drag that over. All right, Javen, do you need help getting caught up? You got it? And we just did number 1 on your blue notes page. So that's as far as we've gotten. All right. And then you're going to hit this green button. Hit the top one, not the bottom one. You just want to sample one time. Click Sample to select an SRS and display the resulting confidence interval. So looking at the confidence interval, where would you go looking for the point estimate, do you think? Where would the point estimate be on a confidence interval? Right in the middle. So this dot right here, that's your point estimate, which I'm going to abbreviate PE. Where do you think you would look for the margin of error? Yeah. This right here tells me what the margin of error is, and it's this distance right here. All right. So what I want you guys to do on your page is you have, let me go back to have a spot right here. I want you to sketch in the confidence interval, including the point estimate. So if I were to sketch my first one, it would look kind of like this. Remember this dot right here in the center, that's your point estimate. The distance from that dot to the end of the little line is the margin of error, and you should record those. So for mine, you need to record your numbers. Mine, I got 0.48 with a margin of error of 0.06. What do you think that green vertical line represents? The true population proportion. We told it at the beginning that we wanted the population proportion P to be 0.5, and so we have this green line right here at 0.5. And then you're going to answer whether or not your confidence interval captures the true proportion. Not all of them will, and that's okay. That doesn't mean you did something wrong. It doesn't mean it's broken. So the green vertical line represents the true population proportion. And then I want you to answer part C for your confidence interval. My confidence interval did capture the true population proportion. I want you now to answer questions 3, 4, and 5. So follow the directions there for number 3. On number 3, you're going to sketch each of those 10, so add 9 more confidence intervals and sketch them on your page. You don't have to label every single piece. And then I want you to do number 4, where you'll hit reset, and you'll follow the directions there. And then do number 5. I'm going to give you guys about 3-4 minutes to do questions 3, 4, and 5. When you get all the way done with number 5, don't close your computer. Keep this up. We're going to keep moving on with number 6 and number 7. We're going to add on to this. So don't exit out of anything when you're done with question 5. when you're looking at your most recent one, this number right here is your point estimate, and your margin of error is what you add or subtract on the end. And you only had to record that for just your first one. No, be right on here. So what happens if you click on this one? There. It tells you your point estimate right here and your margin of error over here.
Because I put the same thing you did, but that one you said our own. I thought you did it from what we did yesterday.
Oh, no, on whatever you got on your screen for your top one. Yep. If you did, that's fine. We're going to answer this one together, but that's okay. No, yours is almost perfect. You'll only have to change one tiny little thing. Yep, that's okay. So getting ready for this lesson, when I went through and did this last night, this is what my first 10 confidence intervals looked like. And there's two in particular that I've highlighted. Why do you think I did these two in a different color? Yes, these do not capture P, which was that 0.50. So of my first 10, and you can look at your first 10 to answer question number 3, that's what I would prefer you do, but when I'm looking at my first 10 drawn here, how many of those first 10 captured the true population proportion? 8. I had 8 out of 10, so 80%. Where have we already seen 80% show up? Yeah, we told it that we wanted an 80% confidence level, right? All right. And I'm going to do number 4 on mine so that I have a number to put up, but you should have done yours. So we hit reset. And we're going to take a total of 100 samples. So I'm going to sample 25 4 times. 1, 2, 3, 4. If you look right down here, it gives you a summary. What was my percent hit on this one? Can you guys see it back there? What was my percent hit? 0.7 or 70%. 0.7, 70%. Did anybody else get numbers close to that? Like 0.79, 0.82, things in the 0.7s and 0.8s? Awesome. So I'm 7. And then it takes a while to get up to 1,000. But we wanted to take this up to 5,000. And if you look, it's got the total running right here. So I'm just going to click this until I get up to 5,000. There I'm at 3,000. 4,000. And finally, 5,000. What's my percent hit now? .82. So I have 80.2%, 0.802. So I got 80.2%. You'll notice the numbers are all hovering right around where? Hovering right around 80%. If we take many, 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 many samples and we calculate a confidence interval for each one, about 80% of them are going to capture the true population proportion. When we make an 80% confidence interval, that means if we use the same process again and again and again, many times, not all of them are going to capture the true population proportion, but about 80% of them will. Did anybody get exactly 80% when you went up to 5,000? Raise your hand if you got close to 80% though. Nice. So that's why we use that about. It's not exactly 80%, but about 80% of them. What do you think happens as you take even more and more samples? It gets closer and closer and closer to 80%. It gets closer to that theoretical probability there. This is how we interpret a confidence level. Yesterday, we had a stem for interpreting a confidence interval. This is our stem for interpreting a confidence level. If I say I am 80% confident that the interval from this to that captures the true population proportion, this is what it means to say that I'm 80% confident, that if I use the same method to gather a new random sample and the same method to gather a new random sample, 80% of those confidence intervals will capture the true population proportion. All right. I want to give you guys a couple of minutes to do numbers 6 and 7. Read the bullet points. Follow those directions. And then write down your observations underneath number 6 and number 7. I'm going to give you guys about 3-4 minutes to do those two. Mm-hmm. Yes, that would be, that's a great question. But yes, clarifying there. When you interpret this in an actual problem, you will put whatever your true population proportion actually is. So the true percent of what have you, whatever that context happens to be. Right, so the directions said without clicking reset, we need to drag the confidence level from 80% to 95% and look at what happens. So when you take the confidence level from 80% up to 95%, what happens? What happens to those intervals? We were at 80 originally. When I take it up, what happens to the interval? Yeah, it gets wider, right? It gets bigger, it gets fatter. The intervals get wider. More of them capture that true population proportion, P. Look at when I was at 80% here. The ones in red are the ones that don't capture the true population proportion. But when I drag my confidence level up to 95%, I have a lot less red ones. So the intervals get wider, and more of them capture that true. We need wider intervals if we want to be more confident. So as our confidence level goes up, our margin of error goes up as well. What do you think that does to your ability to make an estimated guess? Or not estimated, but like an educated guess. If somebody asked you to pin it down, what is the true population proportion? Take your best guess, give me one number. What do you think happens as your confidence level goes up and your margins get wider? What'd you say? It gets harder to pinpoint it down, right? But when we have those narrower margins, we're not as confident because maybe my sample that I took was one of these. Maybe my sample with my confidence interval, I did my sampling exactly the same as I would have in any other circumstance, but I just had some natural variation in my sample that meant that I did not capture the true population proportion. It's kind of like if I were to take a random sample of 10 students here at the high school, and I just grab student ID numbers, I put them all in a random number generator, and I pick out 10, and 8 of those students happen to be seniors. That would not be representative of the school. It doesn't mean that I did my sampling wrong, but I'm not going to get the true population proportion if I'm only looking at the seniors or a majority of seniors. Does that make sense? So you can do everything right about choosing your sample. You have an unbiased sample, but it might still miss, your confidence interval might still miss the true population proportion. So confidence level up, margin of error goes up. So we trade off precision for confidence. What happens to the intervals when we change the sample size? Leave the confidence level at 95%, change the sample size to 20, take several samples, leave the confidence level at 95%, change the sample size to 250, take several samples. All right, so I'm going to go ahead and clear out what we have here. I'm going to take my sample size down to 20. I'm going to take several samples. And now I'm going to change my sample size to 250. And I'm going to take several more samples. What do you notice? There's a sample size of 250. And here's sample sizes of 20. What happens as my sample size got bigger? My intervals got narrower, right? The intervals are much narrower with the larger sample size. As sample size goes up, what happens to your variability? Goes down. As sample size goes up, variability of the sampling distribution goes down. So as n increases, my margin of error also decreases. So if I want a high level of confidence, I want to be 99% sure, not sure, sorry, 99% confident. I'm messing myself up here. I want to be 99% confident that my confidence interval captures the true population proportion. One of the things that I can do to make sure that I'm looking at that precision is by increasing my sample size so that my margin of error goes down. Does that make sense? All right. We are almost done with today. If you want to flip this over on the back side, interpreting our confidence level, here's that stem that we saw. If we take many, many, many samples and calculate a confidence interval for each one, about blank percent, this is whatever our confidence level is, of them will capture the true, whatever our true population proportion is. And then this is what we just saw with our margin of error. As the confidence level goes up, the margin of error goes up. We have a wider interval. As n goes up, as our sample size goes up, the margin of error goes down. So we end up with a narrower interval. I'm going to give you guys, take about 5-6 minutes to do the 5 questions down in the check your understanding. Take 5 or 6 minutes to do the 5 questions in the check your understanding. For number 1 and number 2, you're going to look at those stems from yesterday and today. There's a difference between interpreting the confidence interval and interpreting the confidence level. Interval is what we did yesterday, level is what we did today. Do you like Reese's? You won yesterday. Thank you. You're welcome. What is the confidence interval on this one? Yes. 0.418 to 0.715. That's what the interval is. How would we interpret that in context? Yes. Did you have your hand up? Oh, I'm sorry. I thought I saw your hand up. Camille, did you want to do it?
Sure.
Okay.
We are 90% confident that the interval from 0.418 to 0.715 practices your population of all students in the school that can do it.
Absolutely. And in fact, you got a big chunk of that just in this last sentence right here. The only thing you had to change was instead of he is, change it to we are. And they had that interpretation right there for you. We are 90% confident that the interval from 0.418 to 0.715 captures the true proportion of all students at this school that can do a pull-up. I ran out of room for at this school, so I left that part off, but it should be there. So if that's how I would interpret the confidence interval, let's talk about the confidence level. What is our confidence level here? 90%. So the way we interpret this stem is up at the top of this same page. How do we start this? If we take many samples and do what with it? And calculate a confidence interval for each one, we're interpreting the level. But if I were to create a confidence interval for each one of these samples that I take, about what? About 90% of them will do what? Absolutely correct. So if we take many samples, the same way this PE teacher did, using their same method, we do it over and over and over, and for each one of those individual samples, we calculate a 90% confidence interval using the same method that the PE teacher did. About 90% of them will capture the true population proportion of students at this school that can do a pull-up. How would a 90% confidence interval from a sample size of 200 compare to this confidence interval, where we had a sample size of 30? It's going to be narrower. I would hesitate on using the word smaller, even though I understand what you're saying, because we're only looking at the horizontal distance here. So yes, it would be narrower. Increasing the sample size decreases the margin of error. What would happen to the length of the interval if the confidence level went down to 80%? Absolutely. It's going to get narrower also. If you decrease your confidence level, then you decrease your margin of error. You're going to be narrower. So it would also be narrower. For the decreased confidence level, a smaller margin of error is necessary. So before we go on and look at this last question, that's kind of review, stuff that we haven't talked about for a hot minute. When we say we're 90% confident or 95% confident or 80% confident, that doesn't mean that I'm kind of sure or really sure. It means that if I use the same process over and over and over, about that percent, whatever confidence level I chose, about that percent of those confidence intervals would capture the true population proportion. Does that make sense? I know there tends to be a lot of confusion about this because that word confident, when you're just talking like English language stuff, gets used in a lot of different situations. All right, let's look at this last question here. Describe one potential source of bias in this study that is not accounted for by the margin of error. Bias, if you remember from first semester, has to do with how your data was collected. What do you think about the way this PE teacher took their sample? Not going to be able to generalize to the entire school, even though that's what he's trying to do, because he's only looking at students that are after-school athletes at this time right now, right? What would you call that kind of bias? If you want to be able to generalize to the whole school, but we're not going to be able to because we only pulled from this, do you guys remember what that kind of bias is called? What did you say? Close. He did pick something that was convenient, but he still picked a random sample from those people. We wanted to be able to generalize to a larger group, so what he had was undercoverage. He had undercoverage. Students who are not after-school athletes didn't have the opportunity to be part of the sample. Undercoverage happens when we want to be able to generalize to a larger population, but not everyone in that larger population had the opportunity of being included in that sample. That's undercoverage. The margin of error accounts for natural sampling variability. The margin of error will not fix undercoverage, non-response, or response bias. The reason we have a margin of error, instead of just looking at our point estimate and saying, yep, that's what the population proportion is, we have this margin of error so that we can hopefully capture the true population proportion. But that does not account for a bad sample. Does that make sense? Basically, with statistics, if you start with a bad sample, all your data is bad after that. If you don't have a good sample, you can't do anything meaningful with the numbers. Now, there's other places down the line where you can trip up and make mistakes. But the first most important thing when you're looking at statistics is a well-selected sample so that all of these other skills and tools that we're learning can be used to analyze that data. All right. That's everything I got for you guys today. Homework is due tomorrow. If you've not already done the reading, please make sure you do the reading before you finish up that homework. It will fill in any gaps that you may have between what we did yesterday and today. Again, the reading assignment will be page 536 to 547.